So Module 2, Homework 2, we're going to work on some more graphing problems. Specifically, we're going to look at graphing horizontal and vertical lines. Now these are special lines. Horizontal lines really only cross the y-axis. If you look at one of these lines, it goes straight across here or straight across here or really at any point. It would be completely straight across horizontally, sort of like the floor. We say, as far as those slopes, that they have a zero slope or a no slope. You can write that either way, zero slope, no slope to this line. And an equation for a horizontal line is always going to look like y is equal to some number. In other words, we would have this one where I put the line at y equals 6 would be y is equal to 6. And this one where I put the line at y is equal to -3, that one would be y is equal to -3. It doesn't say anything about what x is because, well, x could be anything along that line, but we know that y is always going to be a constant. It is always going to be 6. When it crosses this line, y will always be 6. When you're on this line, the other line, y is always going to be -3. And we know by that it is horizontal. So vertical lines are just the opposite, as you can imagine. These lines only cross the x-axis. So I could put a vertical line. Let's see, I could draw one here. Not a very good vertical line. Or I could draw one here. Let's use my handy dandy little ruler here. I could draw it here. So vertical lines, of course, can go straight up and down anywhere. Now we say vertical lines have an undefined slope. Or we can also say that they don't have a slope, okay? It's different from having a zero slope when you don't have a slope at all. The equation's always going to look like x is equal to a certain number. The first one I drew, where x would, of course, be, let's see, that looks like -3, doesn't it? This would be x equals -3. And the other one looks like x is 5 here, so that would be an x is equal to 5. Now, x could be anything. But of course, we don't define y because it's every line, every point on that line, every y is going to be on that line for any x value of -3 or 5. So let's do some problems or some graphing with this one. If, for example, you see x is equal to -1, you really don't have to think too hard about these lines if you can remember that that is always going to be a vertical line. So I find where x is equal to a -1, and here it is. On the x-axis, x is -1 here, well, x is -1 here, and here, and here, and here. In other words, straight up and down. X is always going to be -1 at that particular point. So that line is really x equals -1, okay? Now, if you don't remember that, then you would think, okay, I got to point plot this thing. And you would look at your equation, which is x is equal to -1. You'd say, okay, well, x always has to be -1. There's no y in the equation. So any y will do, right? X is always going to be -1. Y could be -50. X is going to be -1. Y could be 200. It doesn't matter. You see, it's all up and down that line. Every possible value for y is going to yield a -1 for x. What about this one, b? It says y is equal to, so y minus 3 is equal to 0, and we don't see an x variable in it, and I'm thinking, okay, it's probably going to be a horizontal line. So I'm going to look at this thing and go, I need to solve it for y. That's the first thing I need to do. I need to get that -3 on the other side. So I'm going to add 3 to both sides so I can get rid of my -3 that's with my y variable. And when I do that, I come up with a new equation. Y is equal to 3. And that looks very much like the horizontal line. I'm reversing horizontal and vertical. Sorry, guys. It looks like the horizontal line that I was thinking about. This is where y is equal to 3, isn't it? So I could say this line is always y is equal to 3. Now, once again, if you don't remember that and you start trying to point plot it, you would look at your equation and go, well, I don't have an x to plug in, but I do have y is equal to 3. Y is always going to be equal to 3, no matter what x values I choose. Y is going to be equal to 3. And that would lead you in the correct way to point plot that line. Let's look at a couple of other examples of lines and just see if we can graph them. Now, these are not vertical and horizontal necessarily, so we're going to probably need to do point plotting with them. In other words, they're not x equal to a number or y equals to a number, are they? So I'm going to pick this one, and I'm going to say I need to find some points that are on this line. And I've already solved the equation for y, so I'm going to pick my unknown x here, and I'm going to plug in what I always plug in. I'm going to start with x of 0. And if x is 0, here's my equation. I would say y is equal to 2 times 0 plus 1. So what's y going to be? Well, 0 plus 1 is 1. Got that one. So let's pick another value for x. I always pick 1 and negative 1. Let's go differently this time. Let's go 2. X is 2 times 2 plus 1. Well, 2 times 2 is 4, plus 1, y is 5. Forgot to write down what I put in for x. I put in 2, didn't I? All right, let's do a negative value. We'll try negative 1 for x. We like that one. So y then is equal to a 2 times a negative 1 plus 1. This is negative 2 plus 1. So it's going to be a negative 1, isn't it? So I'm going to I'm going to plot these and see if they're all in a straight line. 0 on the x-axis, but 1 on the y-axis gives me the point 0, 1. And then I go 2, an x of 2, and a y of 5. Both of those are positive. There I am in quadrant 1. And then I'm going to go negative 1 for x and negative 1 for y. Here I am. And then I'm going to see, did those 3 points fall in a straight line? Looks like they did. So I'm fairly certain that this line, I could label it, it is y is equal to 2x plus 1. That's the linear equation for that one. Okay, look at D with me. Now, I really don't like the format that D is in. I could point plot it, but my math would be difficult when I was trying to solve for x or y. So I want to get either x all by itself or y all by itself. Excuse me. So I've got a negative 1x over here. Why don't I just get x isolated? I'll take and subtract 5y from both sides. And then I end up, I'll come over here so I can see what I did, with a negative x. This cancels, and it's equal to a negative 5y plus 2. Or I could say 2 minus 5y, couldn't I? But next thing I want to do is I want to go, I'm going to stop coughing in just a minute. I need to solve for a positive x. I'd rather that was a positive x. So I'm going to divide all of these by negative 1. In other words, I'm dividing both sides of the equation by negative 1. So negative divided by negative gives me positive x. Negative divided by negative gives me positive 5. Positive divided by negative gives me a negative 2. And now I have things that are easier for my math. And you can do anything that you see that makes that equation easier for you to plug in values for x or y. Now, y is over here in the complicated side of the equation, so I'm going to pick some values for y, and then it'll be easy for me to solve for x. So the first one I'm going to pick is a y of 0. I'll go x is equal to 5 times 0. Well, 0, right? Minus 2. X will be a negative 2. And the next one I want to pick, let's just go 1. And that would say x is now equal to 5 times 1. Well, that's 5. Minus 2, well, that's going to be an x of 3. And let's pick one. I don't know that I really want to go negative on this one because I'm going to get so far negative. I'm going to just choose a y of 2. It'll make it easy. And I'll say x is equal to 5 times 2, which is 10. Minus 2, well, that's x of 8. Well, that goes off my chart, doesn't it? Let me pick something else, just in case I am really curious about what I'm doing. How about I pick a y value of, how about negative 1? Let's see what that does for me. So how about x is equal to negative 1 times 5? Well, that's a negative 5. Minus 2, that's going to give me a negative 7. I'm not getting a whole lot better here, so I'm just going to go ahead and graph it. I'll get rid of this one. I could graph it but I just need really 3. And the first one is a negative 2 and 0. Negative 2x, 0y, there it is. And the second one is a positive 3x and a positive 1y. That's that one. And the next one is a negative 7x. Well, I'll only go to 5, don't I? Well, okay, count over here. let's call that one 7, okay? It's about the same space, I think. 7, -1 would be about here. I'll call that one my -7, 1. It does look like it's going to be in line with the other two. Let's see how good a job I did with that. And there we go. If I could draw a straight line, it would go through all 3 points. So I'm pretty safe in saying that this is the line -x plus 5y equals 2. Or I could say this is the line x is equal to 5y minus 2, or any of those equations. It does come out to be that particular line. Every point on that line, if you found one of these points and you plugged it into the equation, it would make a true statement. And that's really what we're looking for here. Now, next page. In this one, we're going to see if we can find something called intercepts. We've already talked a little bit about intercepts. Remember, I told you the y-intercept and the x-intercept. The y-intercept, x is always equal to 0. It's where it crosses the y-axis. The x-intercept, y is always equal to 0. It's where it crosses the x-axis. So we just want to see if we can remember that as we go through. I've written it up here for you a little bit. X-intercept is always y is equal to 0. Y-intercept is always x equals 0. To find the intercepts, you simply plug in 0 for the correct variable and solve for the other one. So let's solve for the x-intercept. Let's put a 0 in for y. So I've got x plus 3 times 0 equals 6. Well, that's just x plus 0 is equal to 6, isn't it? So really that's just, it's going to be x is equal to 6, y is 0, x is 6. The point will be x of 6, y of 0, and that's going to be my x-intercept. Let's see if it crosses the x-axis. If x is equal to 6 and y is 0, I'm going to be right here. Now let's do the next one. Let's just turn it around and say, what if x was 0? Well, the equation would then be 0 plus 3y equals 6. Well, of course, the 0 would just cancel, and I would divide both sides by 3, and I would have y is equal to 2. So this equation is going to be x of 0, y of 2. Where do we find that one? Well, I'm sitting here at the origin, 0, 0, and I don't go anywhere on the x-axis, but I go a positive 2 on the y. And that's my linear equation, and all I've done is plot the intercepts. Now, usually I say plot another point just to make sure you got them right, but plotting the intercepts is all you really have to do to find this one and figure it out, okay? Let's do another one. We're going to plot the intercepts on this one. We're going to say for the x-intercept, we know that y has to equal 0. So it's going to be an equation of 3x plus, I'm sorry, that's 2x, isn't it? 2x plus 3 times 0 equals 3. 3 times 0 is just 0. So I've got 2x equals 3. I'll divide both sides by 2. And I'll end up with x equals 3/2. Okay, that's not too bad to plot. Let's see what it is. I said y has to be equal to 0, right? X is 3/2. Y is 0, and that's one of my points to plot. 3/2 is 1.5, isn't it? So I'm going to go in an x-axis positive direction, 1.5. I'm not going anywhere from there because this is an intercept, and I'm going to say it's about here. Let's look at the y-intercept. For the y-intercept, we know that x has to equal 0. So our equation becomes 2 times 0 plus 3y equals 3. Well, this is just 3y is equal to 3, isn't it? I'll divide both sides by 3, and I have y equals 1. So that point is going to be an x of 0, a y of 1. Easier to plot. X of 0, y of 1. Now these points are so close together, it's really hard to figure out where the rest of the graph is, but I'm just going to give it a try with my wonderful little iTunes gift card ruler. And that's what your line should look like. Okay, next one. Let's see what we can do with slope. Now we have to be able to understand slope first. It's the way a line slants. the tilt of a line, if you will, okay? So if a line doesn't slant at all, if it is a straight across, horizontal line with a slope of 0, then we say, that's our 0 slope, okay? So that's our y is equal to a number line, isn't it? What about our straight up and down line? Well, that's going to be our x is equal to a number line. And that one, we say it has an undefined slope. Undefined slope and a slope of 0 are two different things, right? A 0 slope is what I would say a floor has. If the house is correctly built, it has a 0 slope. An undefined slope is what I would call a wall. I wouldn't know how to describe the slope of a wall, and we have it as undefined. It's mathematically correct, and we'll prove it to you later, okay? What the other two slopes you have is a positive slope, and that is like you're going uphill as you move from left to right. And a negative slope is like you're going downhill as you move again from left to right. So an uphill slope, positive, downhill slope, negative. Now, let's look at the ways that we can determine slope if we just know 2 points on the line. We can calculate the slope, and this is a formula that you're going to want to memorize, okay? Learn this one if you don't already know it. The formula says take the 2 points, and m is what we use to represent slope. Take the 2 points that you know and take the y-coordinate and the x-coordinate for one of those points and put them over each other in a fraction format, and then subtract the y and the x-coordinates of the other point. Now, it doesn't matter which point you start with or which point you end with. The only thing that matters is that you have the y and the x are of the same point, and the y and x of the same point. You start with the same one, subtract the same one, and you always have y in the numerator, x in the denominator. So this is what we call rise over run. Rise would be the y-coordinate, the movement of the y-coordinates, right? Because that's going to be either an up or a down movement. So rise is either a positive rise or a negative rise. A negative rise, of course, would look like a drop, wouldn't it? Now, x is, of course, the run. Now, run is going to be either a positive run or a negative run. So depending on what we do here, how we're graphing it, we'll just have positive. If we have a negative slope, we'll have the negative in either one or the other. And I'm going to choose to always leave the negative in the numerator, and I'll show you why in just a minute. First, we're going to find the slope of this line. It has a pair of points here. We could graph the line. We could put it on the graph and graph it with just those 2 points. But let's look at the slope of it, okay? If we want to take our formula, we would say slope is equal to, and we're going to have to figure out one of these points is going to be our first point. I'll make this one my first point. I'll make this one my second one. So this is x of 0.1, and this is y of 0.1. This is x of 0.2, and this is y of 0.2. Now, the formula says you start with the second point. It literally doesn't matter as long as you are consistent, but we'll go with the formula. We'll say y of the second point, I'm going to put a fraction here, y of the second point is going to be 2. And I'm going to subtract y out of the first point. Well, that's going to be 3. Then I'm going to put that over, divide by x of the second point, which is going to be 1. And I'm going to subtract x of the first point, which is a negative 5. That's where I have to really be careful, because I have subtraction in my formula, and I also have subtraction in my data. And that causes the double negative, which a lot of you have learned to do this with. Minus a negative is plus a positive. So this is really 1 plus 5, isn't it? So my slope I get is 2 minus 3, which is a negative 1. 1 plus 5, which is 6. I have a negative slope. We could call it a negative 1/6 slope is what we could say. It is going to have, but I'm choosing to use the negative and leave it in the top part of the slope. The reason is this: it's easier to graph. I'm going to just start with one of these points, and I'm going to choose to start with something that's easy, sort of toward the center of my graph, 1, 2, okay? So I've got 1, 2 is right here. And I know that the next point, or the next point that I can find another point on the line simply by following the slope. I would go down 1 and across 6. This is rise. It has a negative rise, and it has a positive run. So I'm using those as my directions. I go down 1 And then I go to the right 6. 1, 2, 3, 4, oops, 5, and 6 out here somewhere. That point is on my line. Hang on, my video camera is messing up. There, I think I got you back. So that point is on my line. Now, if I wanted to go in the other direction and find a point that is over here somewhere, well, it's gonna have to be, different. I would simply reverse those. Instead of going down 1 and to the right 6, I would go up 1 and to the left 6. I mean, I reverse both arrows at the same time. So if I go up 1 and 1, 2, 3, 4, 5, 6, that's another point that's on my line, isn't it? So let's see if I found 3 points and they're fairly in a straight line. Looks like they are. That's how I would find the slope of the line, and then how I would use the slope of the line to graph. If you're not going to have to go backwards with this thing, if you always just want to find the next point of the line, you can always just use this. Always put, if there's a negative, keep it in the numerator. Then you're only going to be going down or up for the first y number for the rise. And then you'll always go to the right for the denominator, because your negative, if they have one, is going to be in the numerator. Okay, let's take a look at 15, where we can do a couple more of these and maybe make this a little clearer for you. So we've got the formula that we're using for slope of the slope-intercept form of an equation, and that is, as most of you have probably guessed by now or have remembered, it is y is equal to mx plus b. M is the slope, and b is the y-intercept. It's just the y-coordinate of the y-intercept, because the x coordinate is always 0. So that's when, if we can get an equation into this y is equal to mx plus b format, then we know the slope, and we also know one point on the line, and that's all we really need to graph this thing. So let's take a look at this one. The first one, example 2a, is really already in y is equal to mx plus b format. I said find the slope, find the y-intercept, and graph it. Well, let's write down. The slope of this one is whatever the coefficient of x is. Now, I'm going to write slope as a fraction, because I've got to use it to graph. Then I know I will go up 2 and to the right 1. Those are both positive directions, aren't they? After I find my point. My y-intercept, or b, is always going to have, y-intercept always has an x of 0, right? The y-coordinate is a positive 4. So all I have to do is find 0, 4, and then graph it using the slope. Well, 0, 4 is right here. And then I'm going to graph this by going up 2 and to the right 1. Well, that's awkward, isn't it? Because it's off my graph. But what if I did what I said and reversed it? What if I went What if I went down 2 and to the left 1? Okay, take it, go down 2 and to the left 1. Same line, isn't it? I can use that because it kind of went off my chart, if I can remember that trick. And there I have graphed the line. Okay, another one. Now this thing is not in y is equal to mx plus b format, and that's the first thing we want to do. We want this format. So we have to solve it for y, basically. Okay, so let's get rid of a positive 2x by subtracting it from both sides. And then I have a negative 4y is equal to remember the x term needs to come first. So I'm going to say negative 2x plus 8. Then I need to divide everything by negative 4, right? All three terms. So this turns out to be a positive 1y. And this is going to be positive, isn't it? Negative divided by negative, and it's going to be 2 over 4, which I can go ahead and reduce 1/2 x. And then I'm going to say positive divided by negative. Well, that's going to be a negative. 8 divided by 4 is a negative 2. So my slope is the coefficient of x, isn't it? When I've got it in the right format, it's 1/2. My y-intercept has an x-coordinate of 0 and a y-coordinate of negative 2. And yeah, that sign does matter, okay? All right, let's see if we can graph it. We start at the only point we know, which is the y-intercept. We know it is 0 and it is negative 2. 0 on the x, negative 2y. So there's my first point. Then I say, from that slope, I say I need to go up 1 and to the right 2. because they're both positive. I'll go up 1 and to the right 2. There's a good point. I could keep doing that, up 1 and to the right 2, couldn't I? I mean, I could also go the other way by reversing it. I could go down 1 and to the left 2. There's another point, just to help me draw it. And so that you understand what you're doing with these slopes, you should try this, okay? And that is the line for my equation, which is 2x minus 4y is equal to 8. And that gives you something to practice when you're working on slopes, and you should until you're sure that you know how to find the slope when you have just 2 points, and how you know how to graph using the slope and the y-intercept.